right, so we're going to take notes on these pages for Ohm's law. Just page 11 is all we're going to take notes on for this. And so first we're going to start with what we refer to as Ohm's law. And what Ohm's law does is it's going to give us a relationship about electricity, the flow of charges through wires, the voltage of a battery, the resistance, the current, and the power. So we're going to talk about all of these in relationship to like a basic circuit, and then also how we're going to use them in class today or this week. And so the first one we want to think about is voltage. Our voltage is really a stored amount of charges. And when I think about the voltage, I think about a battery. A battery is a source of volts. This voltage actually makes me think of like a force that's pushing charges throughout a whole circuit. And so in a little bit, we're going to have wires. We'll have a light bulb. And we're going to think about the flow of the charges. To change the voltage is to change the battery. Make it maybe a battery that has more energy. By changing that battery, I can change other properties about the circuit. So when we think about the voltage, we're going to say that the voltage is going to be that force that's pushing charges throughout our circuit. A charge force pushing charges through our circuit. This in itself is a circuit, a combination of a voltage source, a battery in this situation, and then wires and a light bulb, some type of resistor using that electricity. The variable, the symbol is a V, and the units are volts, also a V. Our current is the flow of charges. The flow of charges. Kind of like almost like the speed of them. To have a quick speed, to have a fast flow of charges, be a big number. Oops. This flow of charges that I see happening here, this flow is my current. I can change other variables to change the current. The current is the ultimate dependent variable. Current has the symbol I. And the units amps, amperes. Next is resistance. Well, when I see resistance, this light bulb is the example of a resistor. I can get rid of this wire there. Maybe I add another wire. I can add another resistor. A resistor really is like anything that's going to use charges, anything that requires charges to work or to run is a resistor. So as anything requiring charges to work is a resistor, a light bulb, a toaster, your TV, your phone charger. And when we say charges, we really mean electricity. The units for resistance are ohms. The Greek symbol ohm looks like this. The last one is power. Power is like the rate at which electricity is used, the rate at which electricity is transferred. So if I said, okay, how long does it take for this charge to travel through the whole circuit? Ready, set, go. That would be the rate at which the electricity is used, or the rate at which the electrical energy is transferred through the circuit. The equation, well, the units for power are watts. Watts. Maybe you've seen your electricity bill in kilowatt hours or kilowatts. The base for that unit is just watts by itself. There's two equations that we're going to be using. The two equations first are the Ohm's law equation. This equation relates the voltage and the current and the resistance. V equals equals I multiplied by R. Voltage equals current multiplied by resistance. The other important equation is the power equation. Power equals current multiplied by voltage. Cool. Well, let's do just a couple practice problems together. We'll start with number 1. A 60 ohm resistor is connected to a 240 volt outlet. How much current is going through the resistor? So 60 ohm resistor is connected to a 240 volt outlet. How much current is happening? So we're going to divide because it's currently multiplying, and the opposite of multiply is divide. So we're going to undo the 60. Plug and chug, and I get what value? 4. Whoa. Let's do number 2. A 9 volt battery creates a current 1.5 amps. How much resistance is there? All right. Solving for R. We want to get the R alone. R is currently multiplying by 1.5. We're going to do the opposite of multiply, which is divide. On to number 3. An object plugged into a 45 volt battery has a current of 3 amps. How much power does it generate? So an object is plugged into a 45 volt battery. The flow of the charges is 3 amps. What's the rate that power is being used? What's the rate at which the energy, rather, is being used? So the power is what we're solving for. The current is 3 amps. The voltage is 45 volts. Let's solve. $135 watts. Last one is number 4. A 75-watt outlet, or a 75-watt light bulb is plugged into a 120-volt outlet. How much current is going through that bulb? The plugins in your house, the plugins in this classroom are all 120 watt or 120 volt outlets. Make sure that looks like an I and not a 1. $120 is currently multiplying. We got to undo it, so we're going to divide.